Okay, on the bottom section here, what we're going to do is we're going to look at identifying whether these are growth or decay, and then what's the percent of, we want the percent of increase or decrease on the particular problems. So these follow the form of y equals a times b to the x. So here our initial amount is 6, so we're starting off with 6 of something, and then we're multiplying it by 1.3. So this is your A, this is your B. And since our B here is 1.3, we're multiplying our initial amount by a number greater than 1. So multiplying 6 by 1 would get you 6, but multiplying by bigger than 1 is going to make it larger, so that's going to make this a growth function. Okay. And now to figure out the percent, well, we're multiplying by the decimal 1.3, so as a percent, this is 130%, because on a percent you move the decimal spot 2 places to the right, so it's 130%. Now, what you have to do is you have to use 100% as your reference, because 100% of 6 will get you 6. So you have to subtract off 100% here, which leaves you with 30%. And that's your actual growth. Because out of the 130%, the first 100%, if you take 100% of 6, you get 6. Now, if you take 30% more than 100, you get it to get bigger than 6. So you have a 30% growth on the first one. On the second one, our initial value here is 3. And we're multiplying in this case by 0.7. Since 0.7 is smaller than 1, this is a decay. Okay. As a percent here, if we move 2 decimal spots, this would be 70%. Okay. Now, if you think of this as a test, if you got a 70% on a test, your grade actually went down. Okay. So again, we're using 100 as our frame of reference here. So if you take 70% subtracted from 100, how much did your grade go down? It went down 30%. So this is a 30% decay in this particular case. On number 3, here our multiplier is 5/4, which is 1.25, and as a percent, this would be 125%. So this would be a growth since it's bigger than 1 or bigger than 100. And then it would be a 25% increase over 100%. Okay? We're going to look at some examples here of growth and decay problems in the next section.